So we are going to practice some multiplication. So you'll notice that the only difference between this and what we were doing at the beginning of the year is now these are going to be written in what's called function notation. And function notation is just a label to give to an equation. So it's telling me that f of x is equal to 3x squared plus 4x plus 2. And g of x is 2x plus 3. And it's asking me to multiply f of x times g of x. So we're still using the boxes. So if we take g or f of x, we're going to write it on the top of our boxes. 3x squared, 4x, and 2. And then g of x is going to go on the left-hand side of our box, 2x and 3. And we're going to multiply each little piece together and then add it up at the end. So 2x times 3x squared would be 6x to the third power. 2x times 4x would be 8x squared. 2x and 2 would be 4x. 3x squared and 3 is 9x squared. 4x and 3 is 12x. And then 3 and 2 would give me 6. I want you to start getting really comfortable writing this in standard form. So we want to start with the biggest exponent and write all the way to the smallest one. But before we do that, let's identify any like terms if there are like terms. So does anybody see some like terms? Kingsley, what do you see?
9x squared and 8x.
Okay, 9x squared and 8x squared. Graham?
4x and 12x.
4x and 12x, and I believe that is it. So we have 6x to the third. If we combine 8x squared and 9x squared, that would be plus 17x squared. 4x and 12x would be 16x, and then plus 6. Any questions, comments, concerns about that? Okay, the next one has a lot of boxes. Unnecessarily. Look at the two things we're multiplying together. How many boxes should we have here?
3 by 2.
Yeah, 3 by 2, which would be 6. So what I'm going to do is I'm going to, get rid of all the extras. I haven't figured out why they have all these extra boxes in this problem. I even looked at like the answer key and they don't even use them. So I don't know, misprint maybe, I don't know. So let us multiply 3y to the 5th minus 2y squared plus, and then 8. And then on the left, y squared and negative 2. So 3y to the 5th times y to the y squared would be 3y to the 7th. Y squared and negative 2y squared would be negative 2y to the 4th. And y squared and 8 would be 8y squared. 3y to the 5th and negative 2 would be negative 6y to the 5th. Negative 2 and negative 2y squared would be 4y squared. And negative 2 and 8 is negative 16. Do you see any like terms? Like terms. Zion, what do you see? Yeah, 4y squared and 8y squared. Again, we want to try and start from in descending order, biggest exponent all the way to smallest. So the biggest exponent is 3y to the 7th. Minus 6y to the 5th, minus 2y to the 4th. If we combine these two, it would be 12 plus 12y squared minus 16. Okay, we're gonna do things a little bit backwards. I'm actually gonna have you guys do the let's practice on your own and let me know when you're done because I want to check your answer. And then we're gonna do the try it together. Digital students, go ahead and send me your answer when you're done with the let's practice number 1, the x minus 1 times x to the third plus 6x squared minus 5. Okay, so for each piece here, you should have gotten x to the fourth, 6x to the third, negative 5x, negative x to the third, negative 6x squared, and positive 5. There was only one set of like terms, which was the x to the thirds. So it was x to the fourth plus 5x to the third minus 6x squared minus 5x plus 5. Very long. And again, we can't do anything else. That's as simple as we can make that. Okay, let's look at the try it and then we'll take a break. So the try it is not very clear what our end goal is. Our end goal is to find the area of the gray shaded region of that envelope. So we have some dimensions that are labeled. Does anybody have an idea of what we could do to just find the area of the gray? Yes. Well, yeah, we're going to use that. No, keep going. You're good. You got it. We're going to use the box method on what? Right. Okay, so we're going to use the box method on L and W to find the area of the entire envelope. So what could we do to just get the gray area of the envelope? Minus what, Zion? The area of what? Do you know what that's called? It's a mailing label. Yeah, it's something you stick on an envelope, like a mailing label. So we're going to find the area of the entire envelope, and we're going to subtract the area of just the label. So we need to use the box method on the whole envelope and the box method on the label, and then subtract. So let's just do the envelope first. So the envelope does happen to be a square because they're the same length. So we have 6 plus 5 times, or 6x, excuse me, times 6x plus 5. And I'm just writing in the space because I don't have room. 6x times 6x is 3x squared, or 36x squared. I'm struggling today. 6x times 5 is 30x. 6x times 5 again is also 30x. 5 times 5 is 25. Yeah, you're right. And we want to combine like terms, the 30x's. So 36x squared plus 60x plus 25 is the area of the envelope. So the area of the mailing label, what two things do we want to multiply together to get the mailing label? Yeah. X plus 2 and x plus 4. That's the dimensions of the mailing label. So x times x is x squared. X times 2 is 2x. 4 times x is 4x. And 4 times 2 is 8. Again, we have our like terms of 4x, 2x. And remember, we said we wanted to subtract x squared minus or plus 6x plus 8. So again, we have the area of the envelope, the area of the mailing label. So let's go ahead and subtract those two things. So we want to distribute this -1. So that would give us -x squared minus 6x minus 8. And then the last thing that we can do here is we can combine like terms. So 36x squared minus x squared. 35x squared. For the x's, I have 60x minus 6x. That would be 54x. And then for the constants, I have 25 and minus 8 plus 17. So that represents the gray area of the envelope, which we've actually already learned the closure property. I'm just going to kind of like refresh your memory a little bit about the closure property. So closure property just means whatever you start with, your answer is that same type of number. So if I like add integers, my answer is always going to be an integer. That's considered closed. So when we add integers, the number that is the sum is also an integer. So a set is closed for a specific operation if and only if your answer is the same type of number that you started with. So are integers closed under addition? The answer would be yes. And the reason why is your answer is always an integer. So we're just going to look at some different operations and sets of numbers and decide if they are closed or not closed under each operation. So go ahead and find this little check box. So the first set of numbers, 0, 1, 2, 3, 4, dot, 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 dot. If you add numbers in that set, will you always get another number that is in there? Yes, so that would be considered closed. What about if you subtract numbers? No. Okay, so if that's fine if we say no, but we need to give an example that proves that. So give me an example of something that would prove that. Still there. Do the opposite. 11 minus 12 or 10 minus 11 would give us a negative number. So I would consider that not closed. What about multiplication?
Yes.
Yeah, so a positive is always going to give us, multiplied by a positive will still give us a positive whole number. Okay, the next one is just negative numbers. So when we add negatives, do we get more negatives?
Yes.
Yes. What about subtraction?
Yeah.
No. Okay, what would be your example?
5 or negative 5 minus 5.
Remember, they both have to be negative.
Negative 5.
That's fine. Negative 5 minus negative 5 is fine. Because we would add these together and we would get 0, and 0 is not part of that set, okay? Or negative 5 minus negative 10 would give us a positive number. What about multiplication? Why not?
Negative 3 times 3, times negative 3 is
positive. Yeah, two negatives multiplied together are going to give us a positive. The next one is integers. We already said that it's closed under addition. Integers are also closed under multiplication. Integers are also closed under subtraction. Sorry, I mixed those up. Subtraction and multiplication. Rational numbers are like decimals, fractions, positive, negatives, all the above are closed under everything. And I'm actually going to add a column for rational numbers. Division. Rational numbers are the only ones that are also closed under division. And then the last one, polynomials. That is things that include variables, exponents, coefficients, constants. When we add those things together, we still get polynomials. When we subtract those things, we still get polynomials. And when we multiply them, just like we did today with the area model, we still get something that's a polynomial. So it's closed under addition, subtraction, and multiplication. Okay, we're going to skip a lot now. I want you to find where it talks about at the fall festival, please. Okay. let me see if I can grab this real quick. Okay, so at the Fall Festival, the senior class sponsors hay rides to raise money for the senior trip. The ticket price is $5, and each hay ride carries an average of 15 people. They are considering raising the ticket price in order to earn more money. For each 50-cent increase in price, an average of 2 fewer seats will be sold. So that makes sense. If things are more expensive, what's going to happen? Less people are going to probably buy that thing. And if it's too cheap, what's going to happen? Well, a lot more people, or you probably won't make it any money because you're not charging enough to like make enough money to profit. Exactly. So we need to figure out an equation that's going to make like that sweet spot, the maximum number of people and profit that we can get from this hayride. So what we need to do is we need to create some equations. The first equation is going to deal with the cost of the ticket. So T of X is going to be cost of the ticket. So right now, how much is a ticket to ride this hayride? Nope, $5. Plus, because they are considering increasing the price by 50-cent increments. So we're going to write that as 0.50 X, because you'll read it says X is representing the number of 50-cent increases. So our ticket price is automatically $5 plus however many 50-cent increases we're deciding to do. But there's a catch here. The number of people that are going to ride the hayride is going to change. So R of X is going to represent riders of the hayride. Right now at my $5, how many people are riding their hayride? 15. Minus, because it says how many fewer people are going to ride the hayride if we increase. How many fewer? 2 fewer. So 2X. And X again represents the amount of times we increase the price. So every time we increase the price, 2 fewer people are going to ride the ride. So hopefully we don't increase the price 10 times, because what happens if we increase the price 10 times? There's negative amount of people riding the ride, okay? So we have to kind of find the area where it's going to give me a maximum. And what I can do is I'm going to multiply these two things together. I'm going to multiply 5 plus 0.50x times 15 minus 2x. And we're still going to use the boxes. That's okay that there's decimals. So we're going to make our 2 by 2 box to get 5 and 0.50x, 15 and negative 2x. I'll give you a second. Please feel free to use a calculator if you would like to do that. Okay, so 15 times 5 would be 75. 15 times 0.50x would be 7.5x. 5 times negative 2x is negative 10x. And negative 2x times 0.50x is negative x squared or negative 1x squared. Both of those would be fine. So again, I would like you to write it in standard form. So our first term would be negative x squared. Negative 10x and 7.5x would be minus 2.5x, and then plus 75. So that would be the equation that this hayride company could use to figure out what the maximum profit would be based on how many riders. And we're going to do stuff like this, but not till like March or April. So like now, we're just going to leave it at the equation. But that's a quadratic equation is what that is. The squared makes it quadratic. Okay, let's look at one more question and then we will be done. Okay, last question. The freshman class is selling t-shirts to raise money for a field trip. The cost of each custom designed t-shirt is $8. There is a $45 fee to create the design. The class plans to sell the shirts for $12. So the first thing we need to do is, what is our variable? So what do we not know right now? The amount of shirts we're going to sell. So we're going to say X is going to represent shirts. And we're going to write a couple different functions. The first one is cost. So C of X. How much is it costing us to make the shirts? Well, that's included, right? $45, and what else? $8 per shirt. So $8 per shirt plus that one-time design fee of $45, which seems like a lot in my opinion, but whatever. Okay, our next function is going to be revenue. Does anybody know what revenue is? The money that what? Yeah, the money you make. Yeah, the money you make for the shirts. So how much are we making on each shirt? $12. 12x. So then the last function we're going to do is profit. So what's profit? Yeah, the amount of money I take home and put in my pocket, because I'm not going to take home $12 per shirt, am I? Because why? Yeah, because I have to use the $8 to actually make the shirt. So I'm actually only going to take about how much left? 4, right? But we want to show that. So we're going to take our revenue. We're going to subtract our cost, because our cost also includes not just the 8, our cost also includes the $45. So we want to distribute that negative to get 12x minus 8x minus 45. And if we combine those like terms of 12x and 8x, we would get 4x, the $4. But we would still have to take away that $45 one-time fee for the design cost. So hopefully we sell at least 12 shirts, because what happens if we only sell 11? You lost $1. Probably not worth it, right? So hopefully we sell at least 12 shirts. I would hope more, but because I don't think $1 is going to pay for this field trip that the freshman class is going to try and go on. But that can at least tell you how many shirts you have to sell to make a profit.